So we studied some conditions under which when Hilbert spaces were involved, a compact operator can be approximated by finite rank operators. So here is another situation where that is possible. Let W be Banach. Assume there exists Pn, a sequence in L of W, each of finite rank, and such that Pnx converges to Pny converges to y for all y in W. Let V be Banach and T from LVW be compact. Show that T is the limit of finite rank operators. So if you took the obvious one, so Pn composed with T from V to W has finite rank. Okay, and for every x in V, we have Pn of Tx converges to Tx by hypothesis, and therefore, so sufficient to show norm Pn minus T tends to 0 at least for a subsequence. We may not be able to show for the whole thing, but it's enough. All we want is T is a limit of operators of finite rank. So we can, if we can show this at least for a finite rank. So by Banach-Steinhaus, norm Pn is uniformly bounded because it converges for each point. So point-wise bounded means uniformly bounded. So norm Pn is less than or equal to C. And then T compact, so K equals T of BV closure is compact, where BV is closed unit ball in V. Okay. And if you have W in K, then norm of W is always less than or equal to norm T, because W is the limit of T of BV. So Tx, x in BV, so norm Tx is less than norm T into norm x, which is less than norm T, and in the closure the same inequality will hold. So you have that norm W is equal to. So define phi n of W equals norm of Pn minus W for W in K. So phi n is a continuous function. Okay, and mod phi n of W is less than or equal to norm Pn plus norm identity, which is C plus 1 times norm W, and that's less than or equal to C plus 1 times norm T. Therefore, phi n's are uniformly bounded. So we will our aim is to use Ascoli's theorem. So we will now look at phi n W1 minus phi n of W2, and that is equal to mod of norm Pn W1 minus W1 minus norm Pn W2 minus W2. Norm of mod of norm x minus norm y is less than or equal to norm of x minus y. So that's less than or equal to norm of Pn W1 minus W2 minus W1 minus W2. and that's less than or equal to again C plus 1 times norm W1 minus W2. So phi n is uniformly bounded and equicontinuous on the compact metric space. So this is a compact K is a compact metric space, and therefore Ascoli theorem implies that there exists a uniformly convergent subsequence. So given epsilon positive, there exists a n such that for all k and l greater than or equal to n, we have sup x belong to BV. So it means mod of norm P and K Tx minus Tx minus norm P and L Tx minus Tx is less than epsilon. So this is, I am just saying that it is uniformly Cauchy, and in particular we have this. That is, for every x in BV, you have norm P and K Tx minus Tx minus norm P and L Tx minus Tx is less than epsilon. Now you keep K fixed greater or equal to n, and you let L tend to infinity. So P and L Tx will go to Tx, so this norm will go to 0. So norm of P and K Tx minus Tx is less than or equal to epsilon. Okay, and this is true for all x in BV. Okay, so this implies that norm of P and K T minus T is less than or equal to epsilon for all k greater or equal to n. Therefore, we have that T is the limit of P and KT. So we have found a subsequence which converges to this, and therefore this. So B, T from V to LP, so one less than or equal to P strictly less than infinity, compact, implies T is the limit of finite rank operators. So solution, you put Pn of x equals x1 xn 0 afterwards for every x in LP. Okay, so you cut it off. So then Pn satisfies the conditions of, so apply it. That's all. H Hilbert space, T in LH, self-adjoint. 1. Show that T square compact implies T compact. 2. If for some n, T power n is compact, show that T is compact. So solution, first part, so let us take xn is a bounded sequence. So there exists a subsequence xnk which weakly converges to x, and you have T square xnk converges in norm to T square x. Therefore, t square x and k minus t square x and k minus x. So this converges in norm, this converges weakly, and we have seen therefore this should converge to 0. But what is this? This is equal to, I take one t to the other side, so t equals t star. So I get t of x and k minus tx, and if I take one t to that side, I will get the same thing, and so I will get norm square goes to 0, that is tx and k converges to tx, that is t is compact. So 2 is now immediate. Suppose t power n is compact. This implies that t power m is compact for all m greater or equal to n, because composition of compact operator with anything is compact. Okay. So this means for L large, t power 2 power L is compact. This implies t power 2 power L minus 1 is compact by what we saw, and this implies that t power 2 power L minus 2 is compact, and so on. This implies that t square is compact ultimately, and that implies that t is compact. Okay, so that completes. So we will continue the exercises next time.